Butterflies belong to the phylum Arthropoda. They are part of the class Insecta and order Lepidoptera. Butterflies are classified into three groups. The first are the true butterflies, which belong to the superfamily Papilionoidea. The second group, the skippers, belong to the superfamily Hesperioidea, and the third group, the moth butterflies, which belong to the superfamily Hediloidea. We will be focusing on two families from the superfamily Papilionoidea, the true butterflies. These families are Papilionoideae, known as the swallowtails, and Nymphalidae, known as brush-footed butterflies.
There are approximately 20,000 species of butterflies in the world, where 13,700 of them are estimated to be true butterflies. About 725 species of true butterflies have been discovered in North America and 321 in Europe. There are about 7,000 species of butterflies in the Amazon rainforest alone. Butterflies are found mainly in tropical climates, as they are near their food source, where there are accessible flowers, therefore they have easy access to food. Almost all butterflies are active during the day. They are all solitary insects. A few species occasionally migrate, but this is not common. The true butterflies are composed of 5 families, where the Papilionodiae and Nymphalidae being the most common. Papilionodiae consists of 550 species, many of which are large and colourful and recognizable, whereas the family Nymphalidae is the most discovered species of butterflies, with about 6,000 discovered so far. They are distributed all over the world. All species of Nymphalidae can be discovered as they are defined by one characteristic, the tricarnate ridges found on the adult butterfly's antennae.
An evolutionary trait in many species of the Nymphalidae family is the marginal eye spot, caused by the HOX gene encoding proteins essential for patterning during the embryonic stage of a butterfly. The eyes on the wings are used for anti-predatory purposes, with large eye spots warning off attackers completely and smaller eye spots attracting the predator but tricking them into attacking a non-vulnerable part of the wing, allowing it to fly away safely. The markings are made up of a UV white pupil with a black ring around it, surrounded by a yellow ring. Another evolutionary trait within the Nymphalidae family is the use of mimicry in the Heliconia species. Closely related Heliconia species exchange protective colour patterns genes promiscuously. The species show both convergent evolution, a process where distantly related species independently evolve similar traits as a result of having to adapt to similar environments, and divergent evolution, an accumulation of differences between groups which lead to a new species. Malarian mimicry is when both the original butterfly and the mimic are toxic or incompatible to predators. An example of this is when the patterns on the wings of the species Heliconius melpomene converge to similar patterns in different species. This convergent evolution enables the butterfly to mimic the wings of other species that use their patterns to warn off predators. This evolutionary trait is useful as the Heliconia species are toxic to vertebrate predators, so the evolution of warning patterns are able to signal to other organisms not to prey on them as they're dangerous.
The Papiliondae are large and colourful with distinctly recognisable forks in their hind wings, giving them their common name swallowtail. There are around 550 species of the Papiliondae and 3 subfamilies including the Baroninae, Parnasinae and Papilioninae. The largest butterflies in the world are part of the Orthodoptera within the subfamily of Papilioninae, known as the birdwing butterflies. Only one species can be found in Britain, known as the Papiliomachia. Identifiable traits within the Papilionid caterpillar is the osmetrium in its prothorax. This is hidden until threatened. Then the larva turns outwards, inflating with blood, and secretes a foul-smelling defensive compound. The venation in the wings of the adult papilionids characterise the swallowtails. The second anal vein extends up toward the wing margin, not linking to the first anal vein, as they would do in other butterfly families, and the second would normally reach the wing margin. Also, the cervical scleresis joins below the neck, anchoring head movement. The main adaptation across the Papiliondae to avoid predators is the practice of Batzial mimicry, where they will imitate the appearance of a more harmful species to warn off predators, gaining them the same advantage without decreasing their fitnesses. However, if the frequency is high in the harmful species, this could then be perceived as a positive experience, resulting in them not attempting to mimic this particular species. There is a high amount of mimetic polymorphism in wing colour, differing to other animals practicing mimicry. For example, the Papilioglaucus are female limited and Papilio canadensis won't perform any mimicry. It is the genetic difference of Y-links that will determine the base colour of the butterfly, whether it was wild type or melanic. Glaucus is mainly yellow due to the level of dopamine within the organism controlled by the single gene. Without this pigment, it would appear mostly melanic, which is the Batsian mimic of Batis filnal, or the pipevine swallowtail. This mimic of Batis filnal wing colour has been proven through studies in southeastern America that there is a correlation between melanic females and the geographical location of Batis filnal, which successfully confuses predators. As certain subsets of females can perform mimicry, this causes an increase in sexual harassment due to the high level of females resembling the male wing patterns. This is unusual behaviour for Batsian mimicry, as it's the males who are more frequently attacked by predators but also don't mimic, thus should lower their fitness to imitate the colour of a male. For example, the female Papilio can adopt up to 3 different wing patterns. This phenomenon led to 2 main hypotheses, the pseudosexual selection and the male avoidance theory, in order to find out the reason for this choice. Pseudosexual selection involves the males aggressively approaching chosen mates, who could resemble a male wing colour, until they become close enough to identify their gender. And the male avoidance hypothesis states that females will appear similar to males to actually avoid harassment from males, as this can be a harmful process and time-consuming, therefore decreasing their fitness. In conclusion to these theories, a study was performed to see if males preferred a mate who had morphed wing colour. By using frequency-dependent selection, they found that males who did perform mimicry did have the least amount of butterflies that were preyed upon. However, their fitness was reduced due to sexual harassment. The other theories showed that fitness was lost through being attacked by predators but suffered less harassment.